So today we're going to be working with the assignment problem. So this is kind of an interesting algorithm. Uh, the assignment problem can be written in terms of a linear program or as a transportation problem. And let's see how to do that. So suppose I've got 4 machines and 4 jobs. Then the typical assignment problem would be to assign one machine to each job, right? And supposedly each machine takes different amounts of time for each job. Okay, so um, the times for each machine and the job are provided in some kind of table, and then our goal then is to make assignments to minimize the amount of time required. So how would this be a linear program? Well, we'd want to what are the decision variables first? The decision variables would be which machines are assigned to which jobs, right? So you could say, for example, Yij is either 1 if it's if machine I is assigned to job J, or it's 0 otherwise, right? And so then we would just sum the Yij times Cij and sum those together, and that would be our objective function. So we could also frame this as a transportation problem. Let's see how that might be done. Each machine has a supply of 1. Each job has a demand of 1. And so each machine job pair has a cost, and that would be the time it takes, for example, or it could be an actual cost. So as a transportation tableau, then you could write it like this. And now you see exactly how you would also formulate this as an LP, right? A linear program, because we know how to convert a transportation tableau into a linear program, and we also know how to convert the transportation tableau into its dual as well, right? And so this kind of comes in handy as an intermediate step to figure out how to work things. And so these costs that you see here are the costs that are put in from the text. This is the text example from 17.5 or 7.5. And so notice that because we just have 1 for each of the supply and 1 for each demand, right? Each cell is either going to be 1 or 0. And so that creates our assignment problem. Okay, you could see though that this might get a little bit overwhelming if you have a lot of machines or a lot of jobs, or just a lot of people, for example, to a lot of tasks. That might be another way of putting the assignment problem. And so we have a specialized tableau that's developed for this algorithm called the Hungarian Algorithm, or the Hungarian method. And that's the algorithm that we're going to use. If you've had some computer science, you may have seen the Hungarian method already, or Hungarian algorithm, because it's a very popular one. Okay, so let's think about our problem here in a table, and these are the costs that we want to try to minimize, or the times that it takes that we're trying to minimize. And I want to think about this in a particular way here. So if I assign any machine to machine 1, it's going to take at least 5 minutes, right, to do that job. So I could put a 5 over in this position, and then I could subtract 5 from each of these values, and I could think of these as like the excess amounts of time that are required for each of the jobs beyond the 5. Similarly, I could come down to the next row, and I could pull out this 2 as the minimum, subtract 2 from each of these values, and then everything here then would represent excess time in excess of the minimum that it would take to finish each job. Similarly, I could do the same thing for row 3. I could pull out the 3, subtract 3 from each of these values, and down here I would pull out 2 for each of these. Okay, and then I could sum these to see what the minimum is at the moment. This is kind of the biggest, well, it's the smallest minimum, I guess. Right, because well, let's just go ahead and do that first, so I don't get too far ahead of myself here. So these are all the minimums that we pulled out. we subtracted each minimum from the row, and so these are excess times in excess of the minimum over here. And then if we sum these together, it's going to take us at least 12 either units of time or cost in order to make these assignments. So no matter how we make the assignments, the cost is going to be 12 or more. Notice that if we were able to make the assignments in the 0 positions, the cost would be 12 exactly. Okay. Now, I've got the minimum for job 1. I've got the minimum for job 2 as 0. The minimum for job 3 is 0. But notice that the minimum for job 4 is not 0 yet. So no matter how I assign the machines to job 4, it's going to take me at least 2 units either of time or cost. And so let's go ahead and pull the 2 down. We're doing the same thing for the columns that we did for the rows. These are already 0 in the first 3 columns, and so if we pull down the 2 in the first or in the last column, we'll see that we now have our minimum as 14. Good. And now what I'd like to do again is I'd like to assign the machines and jobs to the 0 cells. Am I able to do that right now? I don't think so. Because do you see the problem between machines 2 and 4? Right, they're both, the 0 is in the same position, so we're going to run into some trouble. Now, just trying to eyeball this chart is kind of hard to do. So instead of doing that, what we do is we draw lines through the zeros, and we want to do it in such a way as to use the minimum number of lines to do it. So, for example, one way of drawing these lines through the zeros is just to draw 1 there, 1 there, 1 there, 1 there, right? But the problem with that is 4 lines, but I've just I've just canceled out my whole array here. But is there a fewer number of lines I could use to do that? I think there is. If you do a line here, and a line here, and a line here, right? That's 3 lines, and we're able to cover all the zeros, right? And so let's go ahead and do that. And if we do that, then you see that we have some other cells remaining. And the way to think about this is that no matter what happens, I'm going to have to assign my job to one of these other cells. And so it looks like 1 is the minimum, so I'm going to go ahead and subtract 1 from those cells. And if I do that, well, I'm thinking about it in terms of my rows first. So if I'm pulling 1 out of my rows 2, 3, and 4, what happens then is I create negative 1s in these other positions, and so I need to take those out from columns 1 and 3. We'll do that. Okay, here we go. So now I don't want negative 1s here, so I'm going to take out the negative 1. So I'm going to put a negative 1 down here at the bottom, and then that would mean I would add 1 to all of these values. Same thing here. Take the negative 1 down and add 1 to all of these values. Let's go ahead and do that. Okay, so if I do that, I end up with 15 over here for my minimum. I get my zeros back, and now I've added another 0. But notice overall what I've done when I did this problem. When I go from the original tableau here, or the original table, to this, what did I do? It looks like this cell I added 1, this cell I didn't do anything, this cell I added 1, this cell nothing, and then these cells, what happened? It looks like the 1052 became 941, so I subtracted 1 from those. 146 became 035, so I subtracted 1 from those, and I left the 404 alone and the 040 alone. Okay, so therefore, to go from this cell to this cell, what I did was I picked the minimum value out, and then I subtracted that value from all the cells that were uncovered, the 1052 and 146. So I subtracted the 1 from all of those cells, and I added 1 to the cells that had an intersection of the lines. Cells that were just had one line through them didn't have anything happen to them. Okay, and so this is the important operation that we're going to be using in the Hungarian algorithm. So again, we found the minimum and we subtracted that minimum from each of the cells that were open that didn't have any lines. We add one to the cells that have an intersection, and then the ones that just have a single line through them, we don't do anything to. Okay, and so the summary is there in the notes, and now we look at the array that remains, and then we ask ourselves, can we apply, or can we assign the zeros now to our jobs? And the answer is we can. Let's say take M1 to J2, so this cell is covered. M2 to J4, so that one's covered. M3 to J3, so that one's done. And then M4 to J1, that leaves that one for that job. Okay, so now if I figure out what my costs were for that, I go back to the original tableau and I see that the cost for the 1-2 cell were 5, or the time for the 2-4 cell was 5, the 3-3 cell had a cost of 3, and the 4-1 cell had a cost of 2. So if I add those costs together, I get the 15. Okay, now I do have to be a little bit careful when I'm taking these pairings. Oh, I'll talk about that in a second. Let's summarize the Hungarian algorithm here. So the way we initialized, do you remember? We did the row subtraction first, and then we did the column subtraction, and then we repeated the following process. We draw lines through, or cover the zeros with as few lines as possible, and if that number of lines is equal to n, where your problem is n by n, you're always using a square problem here, then you stop. If the number of zeros, or if the number of lines is less than n, then you continue, and as you continue you would find the minimum in the cells that are uncovered. And do you remember the pattern? We subtract the cells from all the uncovered cells, or subtract the value from all the uncovered cells, add the number to the cells whenever two lines intersect. And now I also should mention that when I was running this algorithm, let's take a look over here real quick, I was keeping track of these minimums as I went. A lot of people don't do that, so you don't have to, because at the end of the problem you can just go ahead and compute the cost anyway. It actually turns out that these are useful in another place, but I don't think we'll probably use them, at least for right now. Okay, so you could ignore these minimums if you wanted to and just do the subtractions. All right, and so the Hungarian method then is kind of a nice one. There's a couple more examples in the notes that you have that I've typed up. I spent a lot of time typing those up. The book isn't, I don't know if the book is real good in this section, so you might rely on the notes. Okay, so I wanted to just mention something about when you assign zeros to your jobs. Let's see. I think I better stop here. I think I've probably gone over my 10 minutes, so I'm going to go ahead and break the video here, and we'll pick it up at the assignment of zeros in the next video.